All right, so this is going to be the second video in section 5.2. So if you'll go down to the section that has the header, All Students Take Calculus, this is where we're going to begin on this particular section. So what we want to look at here is which functions are positive. In our 6 trig functions, which of them are positive? And the first thing that we want to notice here is, remember that with your reference triangle, you can go back and find it here. Your reference triangle, remember that your sine and your cosecant values dealt with y's and r's. Cosine and secant dealt with x's and r's. And tangents and cotangents dealt with y's and x's. So have that handy, and also have your SOHCAHTOA handy as well. That'll be helpful here. Well, the first thing is since x's and y's are always positive in the first quadrant, all 6 of my trig functions are positive in the first quadrant. In the second quadrant, so we understand, according to just pre-algebra concepts, that here my x's are negative and my y's are positive. So my sine and my cosecant, these are going to be the only positive values. Remember, sine is y over r, and cosecant is going to be r over y. Well, r's are always positive no matter what, at least for now. And so since my y is the positive there, all the other functions are going to be negative because they use an x in them. All right, so for the third quadrant, notice that our x's are negative and our y's are negative. R is still positive. It's always going to be positive. And so if I tried to use sine or cosine, that would be a y over r or an x over r, and both of those would be negative. The only ones that are going to be positive is tangent and cotangent, because that's going to be y over x, which will be a negative over a negative, or x over y. So the ones that are going to be positive then in the third quadrant are going to be tangent, cotangent. And then in the fourth quadrant, the ones that are going to be positive are cosine and secant. And if you think about it, that makes sense. Here my x's are positive, my y's are negative. So the only ones with just x's in them is going to be cosine and secant. Now, where does all students take calculus come in? You probably already figured that out, but let's go ahead and let me map it out for you. All means all functions in the first quadrant are positive. Students starts with S, so it's sine that's positive. And of course, the partner there is cosecant. Take starts with T, so it's tangent that's positive. And then calculus starts with C, and that's cosine. So that's where that comes from. We've got the all, this one is for the sine. This one is for tangent, and this one is for cosine. You can take a look at this table down here, but honestly, as long as you understand this concept of x's and y's, then you really don't need this table of positives and negs, but it is an interesting thing to take a look at. All right, so let's determine the signs of some of our functions here. So it says determine the signs of the trig functions of an angle in standard position with the given measure. All right, well, first of all, where is 54 degrees? Well, we know that 54 degrees is going to be in the first quadrant. And since 54 degrees is in the first quadrant, then I know that everything's positive. 260 degrees is going to be in the third quadrant. Well, this is where both my x's and my y's are negative. So the first thing is okay, yeah, I know it's in the third quadrant. In the third quadrant, sines and cosines with their partners are going to be negative. Tangent and cotangent is going to be positive because it's either a y over x or an x over y. So it's going to be a negative over a negative. Negative 60 degrees is going to be in quadrant 4. Remember, we have to go backwards. And so if it's in quadrant 4, then I know that my sines and my tangents are going to be negative, whereas my cosines are going to be positive. Now, how do you find the right quadrant. So the first thing that I want you to notice here is that this is written in a really geeky way, but all it means is that tangent is positive. So the first thing that I ask myself, where is tangent positive? Well, tangent is positive in the first quadrant because everything's positive in the first quadrant. And it's also tangent positive in the third quadrant because that's where I have my y's over my x's being negative over negative. This one says that cosecant is negative. Less than 0 is the same thing as negative. So where is cosecant negative? Well, cosecant, remember the partner is sine. Sine is closely related to those y values. Y values are going to be negative in the third quadrant and the fourth quadrant. Y values are negative in those two quadrants. So then where's the overlap? Well, the overlap is going to occur in quadrant 3. All right, on this one, notice that the first thing it says is that sine is positive. And so sine is going to be positive. Remember, sine is related to the y values. So it's going to be positive. Y values are positive in quadrants 1 and 2. And then the second thing that it says is that cosecant is also positive. Well, cosecant is going to be exactly the same as wherever sine is because they're partners. They're reciprocals of each other. So in this case, I have two choices. It's going to be quadrants 1 and 2 where this was going to be true. Are there any quadrants where all 6 are going to be negative? No, there's not. Example number 9. All right, so this time, let's suppose that our theta is in quadrant 3. All right, so the very first thing I'm going to do, I'm not even going to read any further. I'm just simply going to draw my picture, draw a triangle. Notice that my right angle is on the x-axis, and my theta is the angle at the origin. But wait, there's more. I'm also told that my tangent value is going to be 8 over 5. Okay, SOHCAHTOA says tangent is opposite over adjacent. So the tangent of theta, so here's my theta, is going to be opposite. So over here is opposite, and that's going to be over the adjacent. Oh, but wait a second. Something's wrong here. You can't have pick a coordinate in the third quadrant. Notice this 8 is going down. So if it's going down, it has to be negative. And if this 5 is going to the left, we know just by pre-algebra concepts that that x value has to be negative. Okay. But that's okay because negative 8 over negative 5 is still the same thing as 8/5. So that doesn't cause any problems. All right, before we can do anything, we need to find our missing side. So we'll use the Pythagorean Theorem. Leg squared plus leg squared equals hypotenuse squared. And so we've got 89. The square root of 89 does not reduce. It's not something that's pretty. All right, so we've got then that this is the square root of 89. Sine is going to be opposite over hypotenuse. So that's going to be negative 8 over the square root of 89. Don't forget to rationalize your denominator. Absolute necessity there. And the cosine is going to be adjacent over hypotenuse. So negative 5 over the square root of 89, and then I rationalize the denominator. Now, notice I didn't put tangent down because I was given tangent in the original question, so I didn't worry about that one. To get the other 3, what I'm going to do is I'm going to use these for the reciprocal. If you try to do this one and get the reciprocal, you're going to have to rationalize the denominator all over again, so you're making your life harder. So I'm just going to get the reciprocal here. And so we've got negative square root of 89 over 8. On this one, we have negative square root of 89 over 5. And then for cotangent, just go back to what the original was and get the reciprocal of that, which is 5 over 8. All right, then we have something called Pythagorean identities. So you've already had something called reciprocal identities. Then we have the Pythagorean identities. We're going to use these a good bit this semester, not every single day. Like we'll use the reciprocal identities, but we will use the Pythagorean identities a good bit. So the Pythagorean identities, and by the way, the word identity just simply means this is a rule. This is always going to be true. The first Pythagorean identity is sine squared theta plus cosine squared theta is equal to 1. So let me just stop right here and talk to you a little bit about what this means and what it doesn't mean. So let's look at sine squared theta. Basically, this is the same thing as the sine of theta times the sine of theta. What I want you to understand that this is not the same thing as sine of theta squared. The sine of theta squared would be the sine of theta times theta. So these are not the same thing. So this is the one that we're looking at right now for these Pythagorean identities. So you've got sine squared plus cosine squared is equal to 1. The second one that you have is tangent squared theta plus 1 is equal to secant squared theta. And then the last one, 1 plus cotangent squared theta is equal to cosecant squared theta. I don't have anything catchy to help you to remember the first one, but I have something pretty stupid, but still catchy to help you to remember the second two. This one, I usually write the 1 first. They're the same thing, but if I have 1 plus tangent squared theta equals secant squared theta, I have a sentence for that one, and I say that 1 truck is sensational. Okay, so using the first letters in the words there, 1 truck is sensational. That helps me to remember which one that one is. The other one was a little trickier because I have 2 C words. So I just had to be careful. And so this one was even more stupid, but it works. So this one, 1 cot is cascading down the mountain. Yeah, there's not a whole lot of CSC words. All right, so 1 cot is cascading down the mountain, but you just got a mental picture that you probably are not going to forget. A little bit of a reflection here. It says, give an alternative form of each of the Pythagorean identities listed above. And what that means is rearrange this so that it's in a different order. So for instance, you could get cosine squared theta alone by subtracting sine squared on both sides. Or you could get sine squared alone by subtracting cosine squared on both sides. Same thing with the tangent ones. You can get tangent squared on the other side, or you could get tangent squared alone. And I'll let you do the last one. Going to be the exact same idea. We've got some more identities, the quotient identities. I love these. We will use these lots and lots and lots. So the tangent of theta is the same thing as sine over cosine. It's not so surprising that cotangent is going to be the reciprocal. It's cosine over sine. All right, let's look at example number 10. So it says to find cosine and tangent, given that sine is negative. All right, let's stop right there. Where is sine negative? Think about all students take calculus. Sine is negative wherever the y values are negative. So sine is negative in quadrants 3 and 4. And also where cosine is positive. So cosine is always going to be related to the x values. So cosine is positive in quadrants 1 and 4. So the first thing that we have to do is we have to draw the picture in the 4th quadrant. And we're choosing the 4th quadrant because of that given information. So I'm putting my right angle on the x-axis. My theta is at the origin. Now, not only is sine negative, but the sine of theta is also negative root 2 over 3. And remember that this is going to be opposite over hypotenuse. So don't worry about the negative yet. We'll figure out where to put that. So we have a root 2 on the opposite, a 3 on the hypotenuse. Okay, so now where to put the negative? Well, the negative has to go on the leg that's going down. Remember what I said, the radius is never going to be negative, at least not yet. Later in the semester, we'll have some negative r's, but not yet. And then we'll need to find our missing side. So let's do the Pythagorean Theorem. So we have an x squared, that's the missing value, plus negative root 2 squared is equal to 3 squared. So x squared is equal to 9 minus 2. If you don't remember, if you didn't follow that, negative times negative is positive. Root 2 times root 2 is just a 2, so I'm subtracting 2 on both sides. So x squared is equal to 7, so x is equal to the square root of 7. It's positive because that side is going to the right. And I was only asked for 2 of my trig functions. I was only asked for cosine and tangent. So cosine is going to be adjacent over hypotenuse. Root 7 over 3. Tangent will be opposite over adjacent. So it's going to be root 2 over root 7. Don't forget your negative. But then you have to rationalize the denominator. So multiply insides times insides. You'll get a root 14 on top and just a plain old 7 on bottom. Again, don't forget about the negative. In examples 9 and 10, how are the correct signs chosen when square roots are taken? It's all based on direction. If you're going right or up, you're choosing positive. If you're going left or down, you're choosing negatives. All right, example number 11. So notice here that my cotangent is negative. And not only that, I'm just told to draw my picture in quadrant 2. So let's go ahead. We'll draw our picture in quadrant 2. Right angle on the x-axis, theta at the origin. Cotangent, well, remember tangent is opposite over adjacent. So this is going to be adjacent over opposite. Which one is the negative? The one that goes to the left. 24 is going up, so it's positive. Find the missing side. So Pythagorean Theorem. My C value is going to be 25. I'm only asked to find sine and cosine. So my sine value then is going to be 24 over 25. My cosine value will be negative 7 over 25. This table is pretty interesting. I'm just going to hand it to you for now, but this is going to come in really handy when I'm starting to graph my trigonometric functions. But for now, just bear with me on this. I'm just going to hand you the information. Sines and cosines, their range of values is always going to be from -1 to 1. All of their y values will end up being -1 to +1. Tangents and cotangents are always going to be between negative infinity, positive infinity, all real numbers. And then secants and cosecants are going to be from negative infinity to -1, and then also from 1 to positive infinity. So the question that we're being asked is the statement possible or is it impossible by using these ranges? So the first one says that cotangent is equal to negative 0.999. Well, cotangent's allowed to be anything. So yeah, that one's possible. The second one says that cosine is negative 1.7. Well, cosine cannot go outside of -1 to 1, so we would say that this one's not possible. And then last but not least, this one says that cosecant is 0. Well, 0 is not in my range of values for cosecant, so this one we would say is impossible. And that wraps it up for this particular section.